Yeah, hello and welcome back to our YouTube channel. So in this video I'm going to continue the exercises that we just started. We are in question 8. So for those who have not seen the paper, you can check the other videos in the description. I'm sure in the first description section of the first video you will find the link to have the question paper under my Google Drive. Okay, so this is a question on a projectile motion, and the question reads: a stone is projected horizontally with velocity 3.0 meters per second from the top of a vertical cliff 200 meters high. Calculate A. How long it takes to reach the ground. B. Its distance from the foot of the cliff, maybe to where it hits the ground, something like that, which is called the horizontal range. Its vertical and horizontal components of velocity when it hits the ground, neglecting a resistance. Okay, so I think if you have been familiar with projectile motions, there are basically 3 different types that you have to be familiar. So the first one is this cliff. Oops, my phone can draw straight lines, but I've not used it. Let me try and get back to it. So let us say this is our cliff, even though it's not that horizontal line. This is the ground. So we have something like this, and this is a ball. Wonderful. Let us say that's the ball. So the ball is being projected like this, horizontally to the ground, right? This is the situation that we are having here, in which that ball will move like this through the x direction until it comes to fall. This is the height of the cliff. Height of 400 meters, as you see. So to have, the first thing is the height of the cliff. Well, basically in projectile motions, all the other types, well, let me just rush through all the types. Well, there will be no time, so let me just try. The other projectile motion is the one in which the ball will be on the cliff, but it will be projected at an angle. Yes, it will give an angle with the horizontal, different from the one up there, from the one here, right? It will give an angle with the horizontal. That is the another one. Then there's another type that, let us say this is the ground and this is the ball being projected at it goes like this. So for your level, I think this is a tree that you have to be familiar with, and maybe even though the teachers maybe some based on the first and the last, but we'll see as problems, we'll see how to handle all. So let us go straight to the question. So by the way, sorry, I started the question, but I was a bit occupied, so I could not make up with time to answer the questions as I started it. So let me erase back this here and see how to. Let me see. These lines can go a little bit better. Okay, so we are having like this. A ball is here, have been projected to the ground. Okay, with horizontal speed of 3 meters per second, with the cliff height 200 meters. Okay, so basically in projectile motions, at constant speed, you have to know this equation that d is equal to dt. At constant speed, d constant. These are the equations you have to do. But at constant acceleration, there are basically 4 questions that you have to be familiar with. The first one is v equals u plus 20, and the second one is v squared equals to u squared plus 4as, and the last, no, I've started with d, 2ad, and the last one is s is equal to plus 1 half at squared. Or there's another one that s is equal to u plus v, not u naught, u plus v on to all that t, or we say that s is equal to v average t. Sorry, this should be 2 here. So these are the equations that you have to be familiar with at constant acceleration, while this one is the one you have to be familiar at constant speed. So the one v is the final velocity, while u is the initial velocity. Acceleration is, a is acceleration and t is time, and these equations can be applied in both the x and the y directions. If I'm talking about the x directions, then I'll put subscript x here. That would be dx, ux, ax, and maybe d in the x direction, t in the x direction, ax in the x direction, and ux, something like that. So, and y I can still apply. And in projectile motion, there's another thing they have to also master, that we have to understand is that ax is constant and equals 0. Acceleration in the x direction equals 0, and acceleration in the y direction is equal to g, acceleration due to gravity of our planet, which is negative 9.8 meters per second square. Negative 9.8 meters per second square, or per square second. Then there is another thing they have to be familiar with in projectile motions. Vx is also constant throughout the projectile motion. The velocity in the x direction is constant throughout the projectile motion. So now, with this in mind, let us now go ahead and see how we can analyze the question given and know which formula are we to use, and how should we use the formula, and why should we use the formula. So this is our question. So from here, the question says that a stone is projected horizontally with velocity 3.0 meters per second. Horizontally means it is projected straight on the x direction only. So the velocity we are having is what? Is Vx. Vx is 3.0 meters per second. So V equals to 0 meters per second. It is projected on the horizontally in the x direction. This is from the top of a cliff of vertical height that calculate how long it takes to reach the ground. So which question can we use here? Well, we know that height in the equation of motion that we can apply here, we know that s is equal to ut plus half at squared. But if it is in the y direction, then a subscript y is equal to u subscript y t plus half a subscript y t squared. But remember, this our ball is projected with the initial velocity in the y direction, which is uy, equals 0. So sy will be equals to 0 times t plus a half into ay, which is g t squared. So sy is basically what? The height of the cliff from the ground. So 200 meters is equal to 0 times t. This time vanishes, so we have half g like that. So from there we can have 400 meters, and question multiplies equal to gt squared, of course multiply with the 2. And by that we have t will be equal to 400 over g, the square root of that seconds. I can put meters here, second. Meters per square second. So from there we have our t to be the square root of 400 is it 20 seconds. The g is 10 and 9.81. It depends on you. So that's how you can calculate the time it takes for the ball to hit the ground. What have I used here? I've used the equation of motion that sy equals to uyt plus half ayt squared, and we have said that the ball have been projected horizontally, so the initial speed in the y direction is what? 0. So in that case, only sy is left, equals to half gt squared. Some books I see that h is equal to half gt squared. That h is the height of the cliff. That applies. It's the same thing, but it comes from the equation of that motion where the initial velocity in the y direction is 0. That is just how we do it. Then we are also asked to calculate its distance from the foot of the cliff. Well, this is the distance. They call it range. The horizontal distance from the foot of the cliff. So in that horizontal distance, you talk of horizontal, so we are just using our x direction. So I will say that sx you are equals to, so the equation that I can use x is equal to ux plus at, right? uxt plus at squared. That is the equation. But remember, in the x direction. So ax equals to 0 in a projectile motion. Ax acceleration in the x direction is 0. So from here we see that sx is equals to uxt. So if I'm using the total time for the motion, then that will be what? Our we use the total time to determine the horizontal range, and from above this is the time. So from here we can see that fx, the horizontal range, is equal to, I like to see it as range, is equals to 3.0 meters per second times our total time, the time we calculated up there, which is 3.0 meters per second, multiplied by our time, which is 20 root 3 seconds. I simplify that, you just have your value, 60 and 60 seconds. And that's the horizontal range. Oops, what am I saying here? Range, it is 20. This should be meters. This should be meters. Root 60 or root g meters. So that's how you can know the horizontal range. By the way, this is just a little revision on these questions. I will take time and move through the topics. Then they say it's vertical and horizontal components of velocity when it hits the ground. Well, what we said? We said that the v, I can use v is equals to uy plus vy is equals to uy plus at. Similarly, vx, ax, ay, vx will be equal to ux plus axt. That's the first equation of motion at constant accelerations. So these two equations apply. But what do we notice? We notice that uy equals 0 in this our case, and the same time ax equals 0. So our vy, our y direction will be what? A, y, t, because uy is 0. And our vx will simply be what? Ux, since this term will vanish to 0. So our vx equals 0. So vx is not changing. Even from here, you can really see it. So from here, we can calculate our vy. Vy will be equals to v times our time, which our time is 20 on root g seconds. That is our vy. And similarly, our, is it 20 on 20 meters? This is meters per second. So it should be root meters. Yeah, this one should be root meters. Okay, so that is that, to calculate the vy and the vx. As easy as that. And let me see, what did they ask again? It's vertical and horizontal component of velocity when it hits the ground. So that is the vx and the vy. And you can still find the final speed by taking out the square root of vx squared plus vy squared. You have your, and you can still find the direction or the angle it makes, the time inverse of vy on vx. So that is how you can go through these problems, and with time I'll just revise all for now. With time I will see how to go through all the projectile motion topic. And if you have any topic that you suggest we should do videos on, you can still mention it in my email address, or you can still send it through the WhatsApp group that we created to help students if you are one of them. If you are